Hi, this is Radhakrishnan. Welcome to Python tutorial episode 6. Today, I want to discuss more on the data structure in Python. There are four major categories of data structure elements available in any language: stack, queue, linked list, and finally tree. Data structures are very complex concepts. Every program in this world uses any one or all of these data structures. Even our operating system works on this principle. So, understanding data structures is must if you want to become a good developer and solve complex problems. Since data structures are very broad and complex topics to discuss, I will take the simpler ones first and make everyone comfortable with data structure. So, I will discuss about stack and queue in this topic, which is basic element of data structures. And we should see linked list and tree only after we understand about classes. I will discuss about classes in future videos. Please remember, you can become guru in data structure only when you solve more and more problems. Each problem may require different type of data structure. So, data structure needs practice, practice, and practice. If you see how people make use of data structure logics in other core languages like C, C++, then you will understand how Python made all these operations very easy for the programmer, and you will love Python much more. Python made this data structure logic very easy by providing so many helper functions. Let's see stack and queue one by one. Stack. What is stack? In a stack, all operations like insertion and deletion are performed at only one end called top. Basic implementation of stack follows LIFO, meaning last in, first out. Let's see how we can perform these operations in stack. Insertion operation in stack. In stack, generally the insertion operation is called as push operation. Let's see the pseudocode of push operation. First, I'm initializing the top variable and then declaring the push function. As a first step, I'm comparing the top to the stack size to make sure that the stack is not full. If it is full, I'm printing the print message. In the else condition, I'm assigning the element to the top and then incrementing the top to the next element. Let's try to understand the push operation by pushing few characters into the stack. First, I'm pushing the A character into the stack and the top is pointing to A, and then I'm pushing the character B. Now the top will be pointing to B, and I'm pushing the character C, and then finally D. Now the top is pointing to the D. Now let's see the deletion operation in stack. In stack, the deletion operation is generally called as pop. Let's see the pseudocode of pop operation. First, I'm declaring the function and then I'm comparing the top equal to 0 to make sure that the stack is not empty. If this condition is passed, I'm printing the text stack is empty. In the else condition, I am first assigning the topmost value into the deleted variable and then decrementing the top variable. In pop operation, generally the deleted element is returned. So it must be written. Let's try to understand the pop operation by popping few characters out of stack. The stack contains A, B, C, D. I'm trying to pop out the character D. So the top is pointing to D. So after popping out the D, I have only A, B, C. Just like that, I'm popping the elements one by one. The third operation is display operation. Display operation is generally used to print the elements available in the stack without popping out those characters. Let's write the pseudocode for display operation. I'm declaring the function and I'm making sure the stack is not empty. In the else condition, I'm traversing from top to the last character in the reverse order and I'm printing the elements one by one. Now we have seen how the stack actually works. Fine. What are all the uses or where and all the stack data structure can be used? Let's see couple of example of stacks. Example 1, reversing string. To reverse a string, the characters of string are pushed onto the stack one by one as the string is read from left to right. Once all the characters are pushed onto stack, they are popped out one by one. Since the character last pushed comes out first, subsequent operation results in the reversal of the string. Example 2. Stacks are also used to check whether the arithmetic expression containing nested brackets is properly closed or not. In this example, the first column represents all the valid inputs and the second column represents all the invalid inputs. Let's try to solve the problem in the code. Let's get into the shell or ID. Let's create a new file called stack.py. As a first step, I'm getting the user input for the input string containing only the open bracket and close bracket. Then I'm converting this string into a list. This is a stack implementation using the list as the stack, right? So I'm declaring my stack with empty values. Then in the for loop, I'm iterating the characters in the input string one by one. If the current character is open bracket, I'm pushing that character into the stack. If the current character is close bracket, and if the stack is not empty, I'm popping out the previous character from the stack. If the previous character is not open bracket, it is not properly closed. If the for loop completes successfully without the break statement, it means that the string is properly closed. Let's try to execute this program with some inputs. First, I'm giving the valid input. Next, I'm giving some more valid input. Next, I'm giving invalid input. Next, I'm checking with one more invalid input. Like this, the stack can be used to validate the expression given by the user. Let's see our second data structure element, queue. What is queue? In queue, the insertion is done at the end called tail or rear. The deletion is done at the other end called head or front. The basic implementation of queue follows FIFO, first in, first out. Let's see how the logic of insertion, deletion and display on the queue data structure is implemented. Insertion operation on the queue. Insertion operation in queue is generally called as Enqueue. Let's write pseudocode for the Enqueue operation. I'm declaring the head variable, tail variable, and then Enqueue function. As a first step, I'm making sure that the queue is not full by comparing the tail variable with the queue size. In the else condition, I am assigning the element to the tail position and then incrementing the tail position. Let's try to understand the Enqueue operation by inserting few characters into the queue. I'm inserting the character A into the queue. Now head points to A and the tail points to the next position. And then I'm keep appending B, C, and finally D. Here, during the insertion operation, only tail position is moved and head stays at the start of the queue always. Let's see the deletion operation in queue. In queue, the deletion operation is called as dequeue. On the pseudocode, first I am declaring the dequeue function and then I'm making sure that the queue is not empty by comparing the tail and head. In the else condition, I am assigning the head value to the deleting element and then I am moving the head to the next element. As in stack, in queue also the deleted element must be returned. So I am returning the deleted element. Let's try to understand the dequeue operation by removing few characters from the queue. I am removing the character A first and then trying to remove the character B and then removing the character C and finally removing the character D. In dequeue operation, the tail stays where it is and head only moves forward by deleting the element present in the head. Let's look at the other operation, display operation in queue. Display operation is generally used to print the elements available in the queue without removing those elements from the queue. Let's write the pseudocode for display operation. I'm declaring the display function and I'm comparing the tail and head and making sure that queue is not empty. In the else condition, I'm printing the elements from 0 to the tail minus end, which is the size of the queue. Okay, now we have learned how the queue is implemented in any language using the pseudocode. But where are all queue can be used? Messaging system. Mostly queues are used for the messaging system where the order of messages delivered really matters. And the one more major example is scheduling. Mostly the queues are used for making sure that the underlying resources are accessed in sequential manner. One example of queue implementation is process scheduling. Whenever you try to run the process in the OS, the process are inserted into the CPU queue, which then are taken in by the OS scheduler for processing. Since everything happens in nanosecond, you may not have noticed that. Here, the underlying resource is CPU, which is controlled by CPU queue. Let's try to code the job scheduling with some simple functions in Python. Since coding online was taking really long time, I have already completed the queue program, which I will explain it now. As a first step, I am getting the user input for the number of operations or process that I want to queue into the queue, and I'm initializing the queue as a empty one. This is a function which process the element that is taken from the queue and prints the element whatever it gets from the queue. So the async keyword is a special keyword in Python which mentions the Python interpreter to run this function in a parallel thread. I will talk about the thread in detail in future videos. For now, assume if you put async, it will run the function in parallel to the other function. So the process function is taking the max try of 3, meaning it will try 3 times looking for the element in the queue. If it is not finding any element, it will stop the processing and come out of the thread. I'm doing the check for the max try and in the if condition, and I'm making sure the queue is not empty, and then I'm popping out the element or dequeuing the element from the queue and I'm printing that element in the console. If I'm finding the queue is empty because I have already dequeued all the element, I'm incrementing the current try count and then I'm waiting for 1 second in the parallel thread before checking the queue once again. The next function is schedule function, which schedules or enqueues the element into the queue which is processed by the other function. The schedule function also runs in parallel to the process function and schedules the element parallelly into the queue. Here I'm checking the condition for the maximum number of elements scheduled into the queue, and I am printing the element which I am scheduling that into the queue, and I am scheduling the element here, and then I am incrementing the current element count, and before putting the next element into the queue I am waiting for 1 second for the scheduler thread also. This is a main function which creates both of these functions as a parallel task and waits for both the tasks to get completed. And I will talk about the event looping in the future videos when I am discussing about threads and parallel processing. For now, assume that the main thread will be running in parallel to the other two functions. One of the function will be scheduling the element into the queue. Other function will be processing the element present in the queue and printing the output into the console. Let's try to execute this program. I'm giving the input as 3. So I'm asking the scheduler to schedule 3 jobs into the queue. You see, there is a delay, right? So the scheduler schedules the first element and the processing takes that element and prints that on the output. Today's exercise is, in each of these data structures, I have implemented only one examples. So take the other example as your today's exercise and try to complete it. Thank you.